Australian scientists say they have discovered an unknown spinning object in the Milky Way that they claim is unlike anything seen before. Stay tuned to find out what this strange anomaly is and why scientists are so spooked about it. The object has been observed to release a huge burst of radio energy for a full minute every 18 minutes. Objects that pulse energy in the universe are often documented, but researchers say something that turns on for a minute is highly unusual. The object was first discovered by Curtin University honors student Tyrone O'Doherty in a region of the Western Australian outback known as the Murchison Wide Field Array, using a telescope and a new technique he had developed. Mr. O'Doherty was part of a team led by astrophysicist Dr. Natasha Hurley-Walker from the Curtin University node of the International Center for Radio Astronomy Research. She was quoted as saying in a media release from ICRAR that documented the discovery that the object was appearing and disappearing over a few hours during our observations. She added that it was completely unexpected. It was kind of spooky for an astronomer because there's nothing known in the sky that does that. Objects that turn on and off in the universe are not new to astronomers. They call them transients. But an object that turned on for a full minute was really weird. ICRAR Curtin astrophysicist Dr. Gemma Anderson was quoted as saying in the release. ICRAR added that after trawling back through the years of data, the team was able to establish that the object is about 4,000 light years from Earth, is incredibly bright, and has an extremely strong magnetic field. Theories around what the object might include a neutron star or a white dwarf, a term used for remnants of a collapsed star. However, much of the discovery remains a mystery. More detections will tell astronomers whether this was a rare one-off event or a vast new population we'd never noticed before, Dr. Hurley-Walker said. I'm looking forward to understanding this object and then extending the search to find more. Mystery substructures discovered in Milky Way's outer disk. An international team of astronomers led by researcher Shervin Laporte of the Institute of Cosmos Sciences of the University of Barcelona has revealed a new map of the Milky Way's outer disk using data from the Gaia space mission. The findings have been published in the journal Monthly Notices of the Royal Astronomical Society. Typically, this region of the Milky Way has remained poorly explored due to the intervening dust, which severely obscures most of the galactic midplane, says Shervin Laporte, first signer of the article. While dust affects the luminosity of stars, it does not affect their motion. As a result, one can use the star's motion to perform tomography of the galaxy's outermost regions, adds the ICCUB researcher. The team analyzed the Gaia motion data available from December 2020 to identify coherent structures. The map reveals the existence of many previously unknown coherently rotating filamentary structures at the edge of the disk. It also gives a sharper global view of previously known structures. Numerical simulations predict such filamentary structures to form in the outer disk from past satellite interactions. However, sheer quantity of substructure revealed by this map was not expected, and it remains a mystery. What could these filamentary structures be? Our galaxy is surrounded by 50 satellite galaxies and has engulfed numerous galaxies in the past. At present, the Milky Way is thought to have been perturbed by the Sagittarius dwarf galaxy, a fact that confirmed Laporte's earlier theoretical models. However, in its more distant past, it interacted with another intruder, the Gaia sausage, which has now dispersed its debris into the stellar halo. The researchers formulated the hypothesis that states that these filamentary structures are remains of tidal arms from the Milky Way disk, which were excited at different times by various satellite galaxies. Laporte notes that in an earlier study, they already showed that one of the thread-like structures in the outer disk, called the anti-center stream, had stars that were predominantly older than 8 billion years, making it potentially too old to have been caused by Sagittarius alone, but more in line with a sausage origin. Another possibility, adds the researcher, would be that not all these structures are genuine disk substructures, but instead form the crest of vertical density waves in the disk seen in projection, forming an optical illusion that the disk is highly substructured. The team has secured a dedicated follow-up program with the WEAVE spectrograph to study the similarities and differences in stellar populations in each substructure. Through the study of radio velocities, chemical abundances, and potentially stellar ages, the upcoming surveys WEAV, SDSSV, and PFS will also shed light on the origins of the substructures. Unprecedented new telescope image reveals nearly 1,000 mysterious strands in the Milky Way center. An unprecedented new telescope image of the Milky Way's galaxy turbulent center has revealed nearly 1,000 mysterious strands inexplicably dangling in space. Stretching up to 150 light-years long, the one-dimensional strands are found in pairs and clusters, often stacked equally spaced side by side like strings on a harp. Using observations at radio wavelengths, Northwestern University's Farhad Youssefzadeh discovered the highly organized magnetic filaments in the early 1980s. The misdefined filaments he found comprise cosmic ray electrons gyrating the magnetic field at close to the speed of light, but their origin has remained a mystery ever since. Now, the new image has exposed 10 times more filaments than previously discovered, enabling Youssefzadeh and his team to conduct statistical studies across a broad population of filaments for the first time. The information potentially could help them finally unravel the long-standing mystery. Youssefzadeh, the paper's lead author, says that the team has studied individual filaments for a long time with a myopic view. He said that now they finally see the big picture, a panoramic view filled with an abundance of filaments. Just examining a few filaments makes it difficult to draw any real conclusion about what they are and where they came from. This is a watershed in furthering our understanding of these structures. To construct the image with unprecedented clarity and detail, astronomers spent 3 years surveying the sky and analyzing data at the South Africa Radio Astronomy Observatory. Using 200 hours on SARAO's Meerkat telescope, researchers pieced together a mosaic of 20 separate observations of different sections of the sky towards the center of the Milky Way galaxy, 25,000 light-years from Earth. The full image was published in an additional accompanying paper led by Oxford University astrophysicist Ian Haywood and co-authored by Youssefzadeh in a forthcoming issue of the Astrophysical Journal. Along with the filaments, the image captures radio emissions from numerous phenomena, including outbursting stars, stellar nurseries, and new supernova remnants. To view the filaments at a finer scale, Youssefzadeh's team used a technique to remove the background from the main image to isolate the filaments from the surrounding structures. The resulting picture astounded him. While many mysteries surrounding the filaments remain, Youssefzadeh has been able to piece together more of the puzzle. In their latest paper, he and his collaborators specifically explored the filament's magnetic fields and the role of cosmic rays in illuminating the magnetic fields. The variation in radiation emitting from the filaments is very different from that of the newly uncovered supernova remnant, suggesting that the phenomena have different origins. It is more likely, the researchers found, that the filaments are related to the past activity of the Milky Way's central supermassive black hole rather than coordinated burst of supernova. The filaments also could be related to enormous radio-emitting bubbles, which Youssefzadeh and collaborators discovered in 2019. And while Youssefzadeh already knew the filaments are magnetized, now he can say magnetic fields are amplified along the filaments, a primary characteristic all the filaments share. He said that this is the first time they have been able to study statistical characteristics of the filaments, and by studying statistics, we can learn more about the properties of these unusual sources. He made an inference with Earth, saying, if you were from another planet, for example, and you encountered one very tall person on Earth, you might assume all people are tall. But if you do statistics across a population of people, you can find the average height. That's exactly what we're doing. We can find the strength of magnetic fields, their lengths, their orientations, and the spectrum of radiation. Among the remaining mysteries, Youssefzadeh is particularly puzzled by how structured the filaments appear. Filaments within clusters are separated from one another at perfectly equal distances, about the distance from Earth to the Sun. Youssefzadeh and his team also still don't know whether the filaments move or change over time, or what is causing the electrons to accelerate at such incredible speeds. What's next? Youssefzadeh and his team are currently identifying and cataloging each filament. The angle, curve, magnetic field, spectrum, and intensity of each filament will be published in a future study. Understanding these properties will give the astrophysics community more clues into the filament's elusive nature. The Meerkat telescope, which launched in July 2018, will continue to unveil new secrets. What do you think about these discoveries in the Milky Way? Let us know in the comments section below. Don't forget to subscribe, and we'll see you in the next video.